Today we are going to just continue on the path that we started with last week. Last week we did a very simple regression equation, and what we did was we tried to create a machine learning model that could predict the sales from the amount of adverts, for TV and for radio and for newspaper ads, right? So today we're going to do a classification problem. So what we have, the data set we have to play around with is a survival prediction data set. So what the data set is all about is it gives a list of passengers, the ticket classes that they are in. So some are first class, some are business class, some are economy class. All right, then those are the three classes of tickets. Then some are male by gender, some are female, all right? And these are their ages, all right? So this is the status, this is the target variable. In this case, we're trying to use these three variables to predict whether this passenger survives or not. So we try to look at what ticket class did he buy, what gender does he identify with, and we also try to find out the age. So that's basically what happens here, and then if the person survived. So we try to now use this as the basis to train our model to be able to generalize, so that in the event that anything wants to happen, maybe someone wants to board this cruise ship, the person might just use this ML algorithm to just know, okay, so these are the person's chances of surviving in the event that any mishap happens. All right. So that's it. I'm sorry, just give me 1 second. I just need to. All right. So so that's basically what we are trying to do right now. All right. So this is the data set. What's going to happen is I'm going to import the data set into my Jupyter notebooks, and as usual, the culprits, NumPy, Pandas, Matplotlib, and because if you look at these variables, they are categorical. First, we'll have to convert them, all right, to numbers. And there are about 3 different ways we could do that. We could do that by creating dictionaries. We could do that by using scikit-learn one-hot encoder. We could also do that by using pandas.getDummies. And I'm going to use the 2 of them in this session. So this is what I'm going to do. So I'm going to just begin by bringing in the data sets, all right, which is what I did here. And yeah, the data set was on my desktop. I also have it on my GitHub. That's one of the things I try to push to my GitHub. All right.
I can't see the Jupyter notebook. I can see only your folder.
I'm so sorry. I'm so sorry. I thought I was sharing my whole screen. Ow. Oh, sorry. Oh, I'm so sorry. I'm so sorry. I thought I was sharing my whole screen. So, but can you see right now?
Yeah, yes.
Thank you. Thank you, MS. All right. So that means you didn't see the data sets when I showed it. So, so this is data sets in CSV. I just opened it with Excel. I could also have opened it with a notepad. And so, yeah, it's just 3 targets, three features, and then the targets, which is this. So first class, economy, or business class, and then the gender, which is either male or female, and then the age. So based on this, we try to predict whether the person survived or not. All right, so here's my Jupyter notebook. I've imported everything as usual. and I've read in the data set. Like I said, I read this data set from my desktop, but I have it on my GitHub. So much later, I could change it to my GitHub. Still the same data set. All right. Then I bring it in. So I see my data set here. I have label strings here. And then this is the only numerical variable. The rest, P class and sex, are categorical variables. And one of the things we've started learning is that this whole stuff, this whole data frame you see here is just a matrix. And one of the rules of matrices is that all matrices must be of the same kind, really. So everything here has to be numbers for us to be able to run matrix operations on these things. That's why we normally do either one-hot encoding or get dummies or something, because we need to transform this categorical data into numerical before we're able to use our matrix algebra, which is embedded in these functions, to solve these things. So the first thing I did here is to bring out the categorical data sets. And from what you can see here, it's just these two, the P class and the sex, that are categorical, all right? So I have, I have brought out this two, and that's what I did here, all right? So when I run this data set, that's columns, I have it that I have two here, P class and sex. So I count it to just make sure that it's the same number that I have, just to be sure. Then I bring in my encoder, which is the one-hot encoder. So this one-hot encoder is, I'm just instantiating this variable here called encoder as an instance of this class. All right. And some of the parameters I'm using, number one is handle of unknown, which is ignore. Okay, so what does this do? Basically, I know that tomorrow somebody might bring in a data set that has another class, all right? Like right now in passenger classes, we have just three. We have first class, we have economy class, and then we have business class. But tomorrow somebody might bring in a data set, still this same kind of data set, all right, that has something called hybrid class. Okay, so what should my model do if he sees something that is not this three? This parameter here just tells it, hey, when you see any parameter that is not this three, just ignore, convert it to a zero, just, and move on, all right? And then this sparse equals to false tells the model not to make the matrix a sparse matrix. Okay, so this is what I've done. What I've done is I have created a data frame from this instance of the one-hot encoder that I created, all right? And what I've done is I've done a fit transform here. So this fit transform, it's on this categorical data set. So I've just done a fit transform on the P class and on the sex. So what the fit transform does is it's just, converts them to numbers. And I'm going to show you what it looks like much later when we open up the data frames. Okay, so this is it. Yeah, exactly. So this is what it looks like when you run it. So what it does, what one-hot encoding does is that, for example, if you look at this first feature that we're looking at here, which is the passenger class. For this one that is first, you would notice that the system assigns it a 1 and then assigns the other ones 0. So you see that there's a business class now, there's an economy class, and then there's a first class, because the three, what one-hot encoding does is just, it splits up the whole, features into columns, all right? And then assigns weights to them. 0 if that's not the one you're looking for, and then 1 if that's what you're looking for. So that's basically what one-hot encoding does now. So now we got our one-hot encoded column, all right? We've got our data frame. Now, but always remember that when somebody is bringing a new data set from the report or from wherever they're bringing it in, it's going to come in this format. but now your data has transformed to this format, all right? But this is not even all the data. This is just the categorical columns. So there is the numerical column, which is age, which we're going to add right now. So that's this numerical column here that I have here, all right? And then you'd see it here. Then this is our targets column, which is the status, whether they survived or not, and I have that here. So the final data frame that we're going to work on, I'm going to concatenate this one here, which is this one hot encoded data frame. And then I'm also going to add this age, all right? So that way we get our final data frame, which is this. And once we have our final data frame, we can now, I just did this to, just show the type to make sure everything are numbers, all right? So we can now get out the columns, which is passenger class business, passenger class economy, passenger class first class, then sex female, sex male, then age. Age is just one column because it was already a number. We didn't do any one hot encoding on it. But for everyone that is categorical, they will expand because of the one hot encoding. So now we can import our train test splits, and then we can now split into training and testing. And for this, I tried to use two models. I tried the k-nearest neighbors, and I also tried the logistic regression with cross-validation. And I think the second one gave me a better result. So that was why I used it here as my model. All right. So I run my model.fit, and it tells me there's no problem. Then I run my model.predict, and I try to get the shape of my predict to be sure that it's the same thing with the other Y that I have there. And the next thing that I do is I now run the I import the metrics, then I run it so that I get the scores, right? So the accuracy this time is 0.77, which is quite small. Okay, but I mean it's just for like I said, I did not apply any boosting or any feature engineering. I just did vanilla machine learning. If I wanted to increase the accuracy level, probably will apply some other techniques to boost the scores. All right. So as usual, I import joblib. Then when I import joblib, I dump the file with this model, which is the log here, because if you remember, I told you joblib is a tool with which you create pipelines. So just create a pipeline that captures the model. And there are two key parts of the model, two key functions in the model, the fit and the predict. So already when you create that pipeline, you create like an API into that fit and predict. So I have my machine learning model done. All right. So once the machine learning model is done, the next thing we do is we come to Visual Studio and we create a new model. So let me just create a new worksheet, and I'll call that Survivor Streamlit, all right, .py. Okay, so we'll create that then. All right, so the first thing we want to do is to import all our, I'm just going to import, sorry. I have this funny keyboard here that keeps changing. So sometimes you press it and it's a hash, some other times you press it and it's a /. Okay, so import all libraries. That's the first thing we'll do. All right. For starters, the first library I'm going to import would be, okay, so I didn't get to quite use NumPy. So I'm just going to leave that. So import Streamlit as ST. You see that autocomplete I told you about? That's what's happening here. So I have to press a space and then jump it in. Sometimes I get to forget and it puts me in trouble. Okay, so the next thing I'm going to import is my pandas as PD, all right? Then I'm going to import my job lib because I'm going to use it to unpickle that file that we pickled there. All right, then we did not do any EDA, so I'm not going to import matplotlib or any other thing. So just going to run straight into creating our document. So as usual, let's create, sorry, let me just, this is supposed to be a comment. Okay, so create our Streamlit app title. All right, so that's the first thing. Now, I'm going to call this st.title, and I'm going to call this app survival prediction app. All right, so I'm going to run this and let's see how it runs. Okay, so because I have been running Streamlit before, because my Visual Studio was open all the while, so it's still showing me this. Now I could just restart my Visual Studio, but let's see how it plays out. Okay. Okay, so that's the problem. Let me restart my Visual Studio because it still has the other app in memory that I was just playing around with. Okay, so I'm just going to restart my Visual Studio and reinitialize Streamlit. Okay, so once it comes up, all right, cool. So I'm now going to click on run Python file so that it's going to prompt me to activate Streamlit afresh. And once it does that, I'm good. All right, so yeah. Okay. Okay, so almost there, almost there, almost there. Cool. All right, so what I'm going to do is I'm going to copy this streamlit.run like py, and I'm going to paste it here so that I'm going to run it right now, and Python is going to create a browser for me. It's like a local host. All right, so now when I click on this, yep, I get to my new Streamlit app. So cool. So this is my new Streamlit app, just a survivor prediction. Now, the next thing I'm going to do is I'm going to begin to create the input widgets. Sorry, let me make this a comment. It's supposed to be a comment. All right, so create input widgets. Okay, so what are my input widgets? Remember, in the data set, we have just 3 inputs from the class, the sex, and the age. So I'm just going to create, this would be an input box. This would be text input, this would be a number input. So let me just create that here. And so P class, which is the first one, would be a select box because I want the people to be able to select, and it would just read stuff like what was the ticket class passenger paid for. I could just write passenger ticket class, anything. Maybe this is too long. Just use passenger ticket class, right? So this is better. Now I'm going to just a second. Just got a notification. There's something I need to do. Oh, okay. Sorry, just a second. I'm just going to set that. Okay, cool. All right. So the notification is dealt with. All right. So now what are the options that I want to see inside of this? So usually I would have the options as the first class, then there'll be business, and there'll be economy. Okay, so economy. All right. So these are the three classes. Now the next, which is the sex, all right, would be also a select box, and would be like this: passenger, gender, and it would be a list, male and female. All right, so go to the third one, which would be age, and this would be a number input. Okay, so have passenger age, right? And that's just what it's going to be. It's not, we're not putting any bounds. Yeah, we can put a minimum value, we can put a maximum value, we can put steps, we can put all of that from what we have here, but I would rather not do that. Okay, so yeah, so we're good. So the next thing we'll do is, right now we have a problem, because if you look at our Jupyter notebook, you would see that when we did our fits into a model, all right, when we did our fits, our data set had 1, 2, 3, 4, 5, 6 columns, but at the point of entering the data, it just had only 3, which is 1, 2, 3. And when people are bringing in new data to validate this model, it's just 3 features they're going to bring in. So if we just leave this data at 3 features, it's going to mess things up. We're going to get errors when we try to run our model. So what do we do to ensure that we do not get any errors when we're running our model? What we'll do is we're going to try to create a map and tell Python that whenever somebody enters those 3, we want you to take those 3 inputs, put it in the data frame, and run a one-hot encoding on all the categorical features that are inside that input. So it is also like repeating the whole process that we did here inside Visual Studio. All right. So we're just telling Python, hey, when somebody puts in all of this, that's, all of this, want you to take it, make it a data frame, all right, and then do a one-hot encoding on that data, all right. So the first thing we're going to do is we're going to go import that data set. So let's do this. We can call this the mapping prep. All right, so the first thing we want to do right now is to go bring in the original data sets. All right, so let's call that a data set, and it's equal to pd dot read CSV. All right, I'm going to go to my GitHub, and where's my GitHub? Oh boy. Okay, so where's my GitHub? Yeah. All right, so this is my GitHub. So I'm just going to go to survival prediction, and yep, so this is the file. So I'm going to go to survival prediction, the file, and I'm going to go to the raw. All right. So yep, so this is what I need. I'm just going to copy this, and I'm going to go to my Visual Studio and paste this. All right. So this is it. Now, the next thing that I'm going to do is I'm going to divide these data sets into categorical and numerical, just like we did the first time. So I'm going to call these data sets score categorical, and it will be equal to data sets dot drop. All right, so the drop just a second. Okay, so data set dot drop. Now, what columns are we dropping? We're going to drop age. Sorry, I need to put this in inverted commas, and we are going to drop survived. All right. Oh, sorry, my bad. I need to put that in inverted commas. So survived. Then I'm going to tell Python axis equal to 1. And what axis equal to 1 means is that I want you to run this operation on the columns. If I leave it at axis equal to 0, it means I'm telling Python to run the operation on the rows. So I'm telling Python drop the age on the column as I'm column wise. All right. So that's what I'm doing here. Now, the next thing I'm going to do is say data sets numerical, just like we had it in Jupyter Notebook, would be data sets dot drop. And which ones are we dropping this time? We are dropping the P class, because P class is not numerical, it's a categorical variable. We're dropping the sex, and we're dropping survived, because survived is our target variable, so we don't need that right now. And as usual, we're going to say axis equals to 1, so that Python will run that on the columns. Okay, so now we got this. The next thing we're going to do is we are going to now use a dictionary to map the user inputs, all right, like we did the last time. So create a dictionary that maps user inputs, all right. So I've called that input dictionary, all right, and it's going to be a dictionary with the following key value pairs: P class, So P class would be P class, right? Then the sex would carry the value sex, okay? And the age would assume its value from the variable age under the input widgets, all right? So we're good. Now, we will convert this input dictionary into a data frame. So let's just call this input data frame. And let's do pd dot data frame. All right. And we open this. And as usual, if we're using a dictionary, we have to put that in square brackets. So open square brackets inside, and we use the inputs dictionary to create our data frame. Okay, so the next thing we're going to do is we are now going to derive the data frame of just the categorical features. So let's create a data frame. Remember, the whole essence of doing all of this is because we did one-hot encoding. So we're trying to create a map from the input that the users are going to make to the output we used in our .fit and .predict method. So, sorry. So here we're going to derive the data frame of categorical features alone. And how do we do that? We're going to remove age. Remember, when we were doing the one-hot encoding, we didn't encode age because age was already a number. So it's the same thing we're doing here. We're removing age so that we can run the one-hot encoding process here. So I would call this input df without age. I know there are better ways to name these variables, but sometimes it can be tiring thinking of variable names. So it will be inputs df dot drop. So we're going to drop we're going to drop age from here right now. So as usual, open this and drop the age, all right? And also tell Python to run that on the column. All right, so we're good. Now, the next thing we're now going to do is to expand the columns to map these things to the one-hot encoded variables that we got. So I'm going to do this, and I'm going to call this expansion of columns via one-hot encoding. All right, so let's expand this column. So first, I'm going to call this expanded column names, if you like, or you can just call it expanded columns. Now, what is going to be in this place? If you remember when we got to our, let me just go to my Jupyter notebook again. When we ran this, yep, so these were the column names, the expanded columns. It was a list that we got: business, economy, first class, sex female, sex male. All right, so that's all we need. We don't need the age. So I'm just going to copy this, okay? And then I'm going to come paste it here as the list of names. All right, so I could just do this. Yep. So I got my list of names. All right. So this is the expanded columns, the columns that we are expecting when we expand. All right. Now, this is a good place to run our one hot encoding. So we're going to create a new data frame right now. All right. And we are going to, now when we're starting, I told you we could either use get dummies or one hot encoding or something like that for our, we could always use that for our one hot encoding. So initially we used the one hot encoder, but I just want to show you how get dummies works. It's the same results we're going to land at. So let me just do PD. It's a pandas method that gets dummies. All right. And what does it take? It takes the data frame you want to get the dummies for, which is this input data frame without the age. All right. So because without the age, we have all categoricals. So we want to expand them right now. Now, the next thing that it's going to ask you for is columns. You want to drop anything, but in this case, we're not dropping anything. However, we are going to use this method called reindex. So what we're trying to tell on Python is this: create a new set of indices for this this new data frame. And what kind of reindex are we doing? We're changing the columns. So we're now telling you the names of the columns that we want you to use are, sorry, let me make this columns. All right. Equal to expanded columns, right? And then we are going to tell Python to fill value equals 0. So just when you expand, anyone that does not, have that 1 in there, as in it was not the order, just fill it with 0. So that's basically what we're telling Python to do right now. So with this, we can now create, I don't know, I'm running out of variable names, so maybe I should just call this one very new df. Okay, so very new df. And what would be very new df? It will now be a concatenation. So I want to concatenate this new df, which is this get dummies. Remember, when we do that get dummies, the data frame that we had, which was just 2 columns, will blow up to 5 columns. So now we want to concatenate it, which is this new df. Then we also want to concatenate the input df. All right. With just the age column, so that we can have, remember, when we do this PD.get dummies, we'll have 5 columns, including the age. We now have 6. All right. So with this, we'll tell Python, as usual, run this on the columns. So that's what axis equals to 1 means. If I use axis equals to 0, it means I'm trying to run a row operation. Okay, so now that we have gotten to this point, we have finished our mapping. So now we can now import our joblib model. So for joblib, we okay, or pickled model if you like, just in case you like pickle. All right. Okay.
Can I ask a quick question?
Yes, please, MS. I've been waiting for this.
So the code on line 15 to 17, we don't really need to bring in the raw data set.
Okay.
Or do we? Will we be using that?
Well, no, why I brought in the raw data set was so that you can set the boundaries for me. But some people will think you don't really need to, and there are workarounds. But I looked at that there are 2 workarounds that I can use. One is going to be very long and confusing. So, but the second one for me is just, okay, this option of bringing in the original data set and using it to like act like a mold. You know, when we do manufacturing, we use something like a mold, you know, to set the boundaries for other products that we're manufacturing. So that's what I just did with this data set. Truly, like you said, we don't need to bring it in, but I just used it as a mold to create the boundaries and, you know, all the frames that I would need. Yeah, so you're correct. Absolutely.
Thank you.
Okay. So so what I'm going to do now is I'm going to bring in my pre-trained models. I'm going to call this PT model. Okay. And it's going to be my job lib. All right. Dot load. And as usual, if I go to my file where my my documents are, so I could just copy the path by control right click. All right. But since it's in the same file with my Visual Studio, I could just reference the name directly as a relative path instead of just getting the whole path. So I'm just going to come here and I'm going to put the name log reg, since it's in the same place. Yeah. Okay. So the next thing I'm now going to do is to create my predict button. And my predict button, as usual, is going to be a button, Streamlit button. Okay. And the name is going to be predict outcome. Okay. And on click, what should you do? On click, run a function called predictor. Just so I'm going to come here and create that my predictor function as we do in Python. So there's a def predictor. I'm not going to pass any values into it. And as usual, I'm going to call this my model, or M if you like, so that it doesn't confuse us with the other one, which is the PT model. Okay, so M would be the pre-trained model dot predict, because that's what we want to run on the values that we have gotten from the data frame. So we want to run the predict method, right? So the predict method will run that on this data frame called the very new data frame, because already this very new data frame has been expanded to have the six inputs that we have. Okay, so then I'm going to return M. All right. So then the last thing I'm going to do is, if a person clicks the predict button, call this function, which is the predictor. All right. And create a success bar, which is like an output. So say, I'm just going to use a string formatting, the passenger survival prediction for this passenger is, then I'm going to pass the results into this place, and I'm going to save right now. Okay, so now I'm going to run this in Streamlit, and let's see how it works. So when we run, all right, so we have our passenger class, we have male, passenger gender, and age. So let's just play around. Let's say we have a passenger who is business, female, and 40. Let's predict the outcome. Okay, so this passenger is going to survive. What if the passenger is in first class and female is 40? What can happen? Okay, the passenger is going to survive. What if they are in economy and maybe 60 years of age? So what happens? This passenger will not survive. All right. So that's it. That's the first part of the whole stuff. So Rahul, do you get where we had
Yeah.
do you see where we had the issue the last time?
Yeah, but I have an issue with my notebook, I guess, now.
Yes. So that notebook you sent to me, I'm going to have to amend all those columns and map it. So that's just where the problem is on that notebook. It's just the mapping.
Okay.
Yeah.
So I need to map. Yeah, I need to map in my app, right?
Yes, you need to map in the Streamlit app you're using on Python. So you just get to map the input to the one hot encoded variable so that when somebody puts those inputs, then the
Okay.
person can, yeah. So, but I'm going to work on that with you. Maybe after this, we could work on it together, right?
Yeah, sure.
Yeah. So,
Yeah.
so that'd be great. I had to just, okay. Okay, so yeah. So, but do we have any questions? Do you have any questions up to this point?
Not for me. This was great.
Okay,
Thank
thank
you.
you.
Yeah, it was great actually. Yeah.
Great. Okay, so let's now deploy. Now, there are two ways we can deploy this app. We can either deploy via Streamlit or we deploy via Heroku. Okay, so Streamlit usually is my first choice, and Heroku is also good, you know. So, but we could do both of them. Let's see how both of them play out. All right. So the first, if I want to deploy with Streamlit, the first thing I'm going to do is I'm going to create my Streamlit account, which I already have. All right. So let me just get out of here. Let's go to streamlit.io. All right. So I'm just going to open that right now. And okay. So I'm going to sign in. All right. Now, okay. So let me just delete this. This was me playing with the app earlier, and I discovered that it had a bug because of something I was supposed to put on my GitHub that was not there. All right, so this the first thing we're going to do is when you want to deploy an app on Streamlit, you need to tell Streamlit all the dependencies it has to install. So you would need to either do that manually, which means you'd open a notepad documents. So notepad, all right. And you begin to input everything you used, both in your notebook and in your Visual Studio, all the libraries, all right? So you would input the libraries and the versions. Now, that could be a lot of work because it means you have to find out the library and then the version. If you use Anaconda, well, it's still a lot of work, but Python makes us lazy, and that's why we love Python. So there is a module called preprex. So what that module does is very simple. All right. So this is preprex. If you use Anaconda, or if you don't use Anaconda, maybe you have your own Python installed already, you're fine. But if you use Anaconda, you have to go through this to install the preprex. So what does this do? Very simple. By the time you install the preprex, all you just need to do is to point the preprex to the directory where all your files are, all right? So usually when we want to start up a project, we would create a file like we have this one here that contains everything that relates to the project. So all the documents, data sets, everything that would really, just house it in here, all right? And so what preprex does is that you direct preprex to look through all the files in this directory and pick out all the Python libraries that have been used in any .py file. And that's the sad thing. It doesn't read through .ipynb files, just .py files. So if you look at this py file, you would notice that we just have 3: Streamlit, Pandas, and JobLib. But if you look at our Jupyter notebook, you'll see that we had a lot more, like we had sklearn, preprocessing, we had one hot encoder, we had what do you call it now? We had model selection and all of that. So if we just run preprex on this IPy file, we're just going to get 3 of this in our requirements file. But let me just run it now so that you see what it looks like. So I'm going to just copy all the modules that we used, all right? I'm going to copy all the modules that we used here. So I'm going to copy this one hot encoder, and I'm going to put it here. Now, this is a very bad habit, all right? Because I really should not load any module that I'm not going to use because of performance problems, but this is just me just being very lazy. Okay, so I'm going to come here. I'm sorry, I'm scrolling and bring in the next import, which is train test split. I'm going to bring in these, and I'm going to, okay, so yeah, thank you, MS. I'm going to bring in this so that it would also catch that. And yeah, so I think that's about it. And obviously my job lib is here. So now when I save this, I can now run my command prompt. So let me run my command prompt. So I'm going to go to, again, like I said, I use Anaconda, so I'm just going to use my Anaconda prompt. But if you are not using Anaconda, probably are going to use your CMD, all right, your command prompt, your regular command prompt. So now this is my base folder where everything is, all right? But this is the directory. This is the directory where, this is the path where everything is, all right? So I'm just going to copy the path, all right? I'm just going to copy the path, and I am going to come to this place and tell my Anaconda prompt to change directory to this path. So when I do this and I press enter, you'll notice that right now my Anaconda prompt has changed directory to this folder where this stuff is. So now I can now run preprex. Remember, if you did not have preprex installed, you'll have to use conda install preprex on your Anaconda prompt to do that. So it's just conda install preprex, and you're fine. Okay, let me just get that here. Okay, yeah, so conda install, yeah, so just pick this one here and just run it on your command prompts and you're good. Okay, but because I have it installed already, I'm not just going to bother trying to do that. So what I'm going to do now is I have this, I'm now going to run preprex. So what's preprex going to do? It's going to now run through all the files all the .py files in this directory, the survival prediction folder, and try to pick out all the modules that I used in them. All right, I had to delete the former one because I'm running another one also, so that it doesn't clash. But hey, it's going to run now, and once it's done running, you'll see what will happen. It will just pick out all the modules and their versions, and it will host them in a notepad document and tell me, okay, so this, all the files, all the stuff you use have now been, all the stuff you use have now been put into the notepad documents. Yeah, my laptop can be a bit annoying sometimes, but it's going to happen right now, shortly. So once that happens, we know that we are ready. Again, the reason why we're doing this is because we're lazy. And okay, no, we are not lazy. You guys are not lazy. You guys are hardworking. Me, I could be very lazy sometimes. So the reason why we're using preprex is because we do not want to go start picking all the requirements one by one. Scikit-learn version 1.0.1, joblib version this, like that. Pandas version this, NumPy version this, etc.
So I noticed you had only requirements file in the folder. So if you're using Streamlit, you just need requirements. You don't need setup and proct file like we use in Heroku.
Yeah, if you're using Streamlit, you don't need all of those. You just need a requirement file. Yeah, and that's it. Yeah. So this is it. You can see right now. So info successfully saved the requirements file. And
we can't see your screen.
oh, I'm so sorry. My bad. Okay. Okay, so can you say it now?
Yes.
Okay, cool. So this is it. Yeah, successfully saved requirement file in C. All right. So now when I go look at this, so this is my requirements file. You would see a list of all the, yeah, all the stuff I used and their versions. So that's just the whole idea behind the installation of preprex and using preprex. But I could have always have opened the notepad document, gone to my Anaconda and just picked all of this one by one and entered them without having to wait this long. Yeah.
Perfect.
Okay, so once we have our requirements file, the next thing we'll need to do is to create our repo on GitHub. I hate to use Git bash. I hate Git bash. I hate, sometimes I want to cringe when I see Git bash. Okay, so, but, so this is what I use. It's the desktop application for GitHub, all right? And it's free. You can get it online from the Git website itself. So this was created. So this saves me from having to write any Git code at all. Git, yeah, it just saves me that stress. I don't get to see my command line at all or Git bash. So I just do everything from here. So what I do is when I want to add a new repo, I come here, put in the name of the repo I want to add. All right. Then you click on add repo here. And I changed the name of my default branch from master to main. So that's why you're seeing main here. It's not really a problem if yours is showing master, all right? So once I do that and I, add the repo, then it brings out that prompt that tells me, yeah, if there are any changes that are made. So what you will notice is that the moment you install this GitHub for Windows, it creates a folder in your, what do you call it now? It creates a folder in your documents directory where you just drops all the files you're working with. So what I did is when I was setting this up, I set it up in such a way that I created Visual Studio as the place where I get to make amendments to any stuff I do on this. So if, for example, I want to commit this, I'm just going to, because I just changed the requirements file. That's what it's telling me right now. The requirements file has changed. So I'm just going to, summary would be change of requirements file. All right, and description, you could just change in file contents or just anything. Just okay, so I'm just going to commit this to main. Okay, so I'm going to commit this to the main now. All right. And yeah, so it's telling me, do I want to push this into my GitHub because I've connected this to my GitHub online. All right. If I want to edit this code, this whole folder in Visual Studio, once I just click open in Visual Studio, it just opens up this whole workspace that I'm doing this survivor production and prediction in. So you see it here, you see all the files inside, and then any change that I make here, it's automatically committed. And you would see that stuff here telling me you just made some changes. Do you want to push this to GitHub? So I'm just going to push this because I made some changes to my requirements file. So it's pushing right now. And yep. So if I go to my GitHub and I open it on the GitHub app. Okay, so if I open my GitHub, you'd see that the requirements file has been updated. All right, so it's my survival prediction. And so you see the requirement file was just updated 1 minute ago. So this saves me from having to look at Git bash for anything. So I don't use my command prompt. And that was why they created it, for people that hate typing code. So I know some of you like codes, but not me, not me. Okay. So here we are. I have all my files. But when we want to deploy a hierarchical, I'm going to use the dots. I'm going to create the proc file, and I'm also going to need to create a setup.sh file. All right. So I'm now going to streamlit.io, where I have logged in before. And so let me just close this. So this is my local host. Let me just open streamlit.io and log in with Git. Okay, so I'm going to sign in, but yeah, I'm still signed in though. So it's just going to pop in straight up to my account. And yep, so this is it. So I'm going to start to build a new app. All right, and I'm going to click on the new app. The first thing it's going to ask me is for my repo. So I'm just going to refer it to, because I have already connected. You can see this is my GitHub. I signed in with my GitHub. And it's usually good if you sign in with your GitHub, it saves you the stress of having to do a lot of typing. So it will just refer me to the survivor prediction repo, and the branch is the main branch. Then the app is the survival.py app, because that's where all the dimensions of the Streamlit app are present. Now, I like to change the Python version to the latest 3.9. Because if it's 3.7, there are some codes that might just be there, that might not be there. There's some dependencies. For example, if you look at this, my file, oh, sorry, where's my Streamlit file and my requirements file. If you look at the requirements file, you'll see that I like to update my pandas and all this other stuff a lot. So some of this might not run on Python 3.7. All right, so that's why I like using the latest version of Python that is available on the on the on yeah on the Streamlit side. So I go to 3.9 and I click on save. So yep, I'm ready to deploy my app, and let's hope there's no error, because if there's an error, I'm just going to cry right now. Okay.
So I'm assuming it's free.
Yes, it is.
Streamlit?
It's free.
Okay.
Yeah.
And how many apps does it let you deploy?
It's
for free?
unlimited. But the only problem with this is your apps are public.
Oh,
So
okay.
sometimes you might even get a mail telling you about, hey, can you check out this Streamlit app? And it's your app. Like, oh, there's no privacy at all. You only
And-
get one private app.
Oh, one private app. Okay.
Yeah, only one. Unless you upgrade to the paid plan.
I see.
Yeah. Okay.
Heroku let you do 5 for free, but I'm not sure if they're public or
Well,
private.
no, I think it's 3 private apps you get. I think it's 3.
Oh,
I think
see.
it's 3. Okay, I think there were no errors. Yay! Okay,
Wow.
so no errors.
Congratulations.
Okay, so
Great.
yeah, so female and the age is 40. So predict outcome. Great. So yeah, so we deployed very well.
It's very
Alright.
simple.
It looks simple, right?
Yeah.
Yeah, that's why it's so you can just copy this URL and just share it to your friends to just check out your app on Streamlit. And yeah, so that's it.